Today, we are diving into the critical role of the crankshaft position sensor, exploring its key failure symptoms and learning how to test it. Without this vital component, your engine would struggle to function correctly. Why is the crankshaft position sensor so essential? It's the sole part tasked with monitoring the precise position of the crankshaft, a robust, roughly 2-foot-long metal piece within your engine, directly linked to the pistons. As the pistons move up and down, producing significant linear force, the crankshaft spins, transforming that energy into rotational power. This rotation drives other vital vehicle components, ensuring the engine operates seamlessly. In modern vehicles, the crankshaft position sensor relays critical information to the engine control unit, ECU, regulating fuel injection, ignition timing, RPM, and more. But when this sensor begins to fail, chaos can ensue. Stick around as we explore the signs of trouble and how to address a faulty crankshaft position sensor. Number 1. Signs of a failing crankshaft position sensor. Unusual exhaust odors. A malfunctioning sensor can throw off engine timing, leading to incomplete combustion. Unburned fuel escapes into the exhaust, producing strong smells like sulfur or raw gas. If left unchecked, this can harm your catalytic converter. Reduced fuel economy. When the sensor falters, it disrupts fuel injection and ignition timing, causing inefficient combustion. Your engine consumes more fuel than needed, dropping your miles per gallon noticeably. Rough idling. Faulty signals from the sensor to the ECU can upset the fuel-air mix and timing. This results in shaky idling, with RPMs fluctuating unpredictably, making the car feel unsteady even when parked or stopped. Cylinder misfires. The sensor delivers real-time crankshaft position data to the ECU. If it fails, erratic or absent signals can disrupt firing sequences, causing cylinders to misfire, especially during acceleration or at high RPMs. Sluggish acceleration. A failing sensor delays accurate data to the ECU, hindering timely adjustments to spark and fuel delivery. This causes hesitation or poor throttle response, especially when speeding up. Inconsistent starting. A completely failed sensor prevents the ECU from detecting crankshaft position or RPM, disrupting spark and fuel timing. Initially, starting may be difficult, and eventually, the car might not start at all. Note that wiring or circuit issues could also be to blame. Unexpected stalling. Stalling can occur at any speed, posing a safety hazard, especially in traffic. A faulty sensor disrupts engine stability, leading to sudden shutdowns and compromised drivability. Check engine light activation. An overheating or malfunctioning sensor may trigger the check engine light. Cooling the engine might temporarily resolve this, but if the light persists, a scan at a shop, or with your own OBD2 scanner, is recommended. Erratic tachometer readings. A failing sensor sends inconsistent signals, causing the RPM gauge to spike or drop unexpectedly, even at steady speeds or while idling, due to inaccurate crankshaft position tracking. Number 2. How to test the crankshaft position sensor. You'll need a multimeter or oscilloscope, depending on your sensor type. Here's how. Locate the sensor, find it near the crankshaft, often by the pulley, on the engine block, near the transmission bell housing, or behind the timing cover, depending on your vehicle. Testing a 2-wire sensor. Disconnect the sensor and set your multimeter to resistance mode. Touch the leads to the sensor terminals, readings typically range from 200 to 1200 ohms, check your manual. Reconnect, switch to AC voltage mode, and crank the engine. Look for 0.2 to 2 volts, no voltage suggests a fault. Testing a 3-wire, Hall effect sensor. Disconnect and set the multimeter to DC voltage. With the ignition on, engine off, test the power wire to ground, expect 5 or 12 volts. Reconnect, then measure the signal wire to ground while cranking, voltage should toggle between 0 and 5 or 12 volts. Use an oscilloscope on the signal wire to check for a steady square wave pattern. Analyze results, compare readings to your vehicle manual specs. No fluctuation or out-of-range values indicate a faulty sensor needing replacement. Driving with a bad sensor. Avoid driving more than a short distance with a failing crankshaft position sensor, as it risks stalling, power loss, or complete failure to start. Replacement cost. Replacing a crankshaft position sensor typically costs $120 to $400, including parts, $50 to $150, and labor, $60 to $250, varying by vehicle make and model. We've covered the main symptoms and diagnostic steps for a faulty crankshaft position sensor. Stay proactive to keep your engine running smoothly.